Okay, pre-algebra, let's go ahead and get started with Chapter 9, Section 5. We are looking at slope. So here in your notes, I wrote bunny slope. That's what I'm used to. When I went skiing that one time in Pennsylvania, I did the bunny slope. So skiing a baby slope that isn't steep. In math, when we calculate how steep a line is, that is called slope. Another phrase to describe slope is rate of change. And I don't remember seeing that in your book, but it will be discussed if there's a question that says, what is the rate of change of whatever function? What that means is, what is the slope? Slope, rate of change, same thing. So when we're calculating slope, we're looking at two things. We're looking at the rise and we're looking at what's called the run. The rise is the vertical change. That makes sense, right? We have rise and that's vertical. If I could spell vertical, vertical. There you go. And the run is the horizontal change. Okay. So that's the change of x. Okay, so this is change of y and this is change of x. And I think my little drawing thing is going to work for you now because I just want to show you something real fast. Or you know what? No, I'll do it in a little bit. No. Go away, pencil. There you go. The slope of a line is the ratio of the rise to the run. And remember, ratios can be expressed as fractions. So your slope will look like a fraction sometimes. The letter M usually represents slope. We'll get into that a little bit more later. A completely horizontal slope, and a horizontal slope will look like this line right here. Okay, a completely horizontal slope will have a slope of 0. A vertical slope, vertical going up and down, the slope will always be undefined. Me and my spelling again. Okay, let's take a look at our first. Okay, so those are some, here's some good pictures. Check out this slope over here. This slope is positive. You see how you're going uphill? Uphill is positive slope. And it's not that steep, right? It looks kind of like a bunny hill slope. Over here, I have a steeper slope. So this shows me that this slope is going to be bigger than this slope, but this is going downhill. If I were to stand up here or put a ball down here, I'm just going to drop all the way down. So this is a negative slope. And here's this little girl that looks like my sister actually, with some notes for you if you want to need help remembering what each slope would look like. Okay, example number 1. Find the slope of the given line. So we have point A and we have point B. So the first thing we're going to calculate is the rise. Okay, rise goes first. So we're going to start at I'm going to go ahead and start at point B, and I'm going to count up to A. 1, 2, 3. Okay, so here it's saying -3, right? Because if you started at A, then you're going down to B, and that's -3. I can just tell that the slope is negative because it is going downhill. And then my run is the difference in their x values. Okay, so the difference in y values was 3. The difference in the x value is 1. So your fraction is going to look like -3 over 1. You can simplify that, and it is -3. So that is the slope of this line. And here we have the slope formula. So all of these, I know when I was taking pre-algebra, I hated seeing subscripts. These things are just the most confusing things to me. I didn't understand why they existed. So I just want to reassure you that these subscripts, although extra numbers, are just indicating first and second. So what they're saying here is the second point, and then so this is the second coordinate and the second y coordinate of that second point. Sorry, my husband just texted me, but I'm almost done. Okay, and this is your first point. So this is your first x coordinate and your first y coordinate. So here we're calculating the vertical change. That's your second y coordinate minus your first coordinate, y coordinate, and then horizontal change. And that's calculating the differences between your x's. So this is where I wanted to draw a quick example. Okay. Ooh, there's my horizontal line. That's not too great, but bear with me. Let's see, 1, 2, 3, 4, 5. Okay, if I wanted to ask you, what is the difference between, this is -2. Oh man, I hear baby crying, so I'm almost done. What is the difference between 5 and -2? There are two ways you can do this. You can count on your number line, 1, 2, 3, 4, 5, 6, 7, or you can do this, 5 minus -2. And when you do 5 minus -2, we have those two negatives that turn into a plus sign, and this is going to be 7. So that's where that formula comes from. You're really just figuring out what's the difference between the y values that goes on top and the difference between your x values. And it doesn't matter which point you choose as first point, so long as they're on the same side. So if you notice here, the 2's are on the left and the first point is on the right. So just, you can't have second y here and first x here. That's going to give you the wrong slope. So just be sure that you're using that. This is one point on the left and the right is the second point. Okay, so here we're just plugging in these points into our slope formula. Again, don't get confused with all the subscripts. It's just we're doing 5 minus 2. Here's our two y coordinates. That goes on top, and then 7 minus 1 goes on the bottom. So that's 3 over 6, and we can simplify that to 1/2. So that is a positive slope, and it also will not look very steep. Okay, so you're going to be doing that for the next couple of examples. See if we have any more notes. And nope, that is it. All right, so let me know if you have any questions. Feel free to email me at cdundon@wakallachristian.com if you have any questions. All right, I'll see you guys at the next video.